Okay, let's talk about how to predict the formula of an ionic compound. So typically you will see it presented like this. Let's say I want you to tell me the formula of magnesium iodide. Okay, the way you go about doing that is you have to look at the periodic table, because at this point you know it contains magnesium and iodine, so you look at the periodic table. Magnesium is one of the things that becomes a +2 when charged, so I know that magnesium iodide involves magnesium 2+ ion. Iodine, I find that on the periodic table right here, and I know it's a -1. So I know, okay, magnesium and then iodine minus charge. Now, here's what I'm going to do. My personal favorite way to figure out the proper formula, how many magnesiums and how many iodines combine, is the crisscross method, because I should say a proper formula needs to make it so that the amount of positive is equal to the amount of negative. So actually, let me back up a sec before I do that, because in order to balance it out, if this is a 2+, I'm going to need 2 of these 1 minuses. 2+, 2-, that would balance out to neutral, because when you put them together, they should cancel out. So that's why I would choose 1 magnesium and 2 iodines, and I'm going to represent that this way. Now wait, how else could I have gotten that? I was going to mention my favorite way, the crisscross method. Let's do that too. So I have magnesium, that's a 2+. I have iodine, that's a 1-. What I'm going to do is simply put this 1 right here. There's the 1. Take this 2, put the 2 right there. There's the 2. So that's 1 magnesium and 2 iodines. Now, this is a big no-no. Never ever write the number 1 in a chemical formula anywhere. Unless it's part of it, I guess, unless it's part of another number, like 10 or 11 or something. But anyway, that means the final version is magnesium iodide. So it's kind of a sloppy I right there, but you get the idea. Okay, with 1 magnesium and 2 iodines. Now, this crisscross method is generally pretty good about giving results that are correct, that there are some hang-ups, but let's just practice with a couple more of these. Okay, so let's see. Sodium fluoride and aluminum sulfide. Okay, sodium fluoride, I looked them up on the periodic table. Sodium is a +1. Fluorine is a -1. All right, so I can say sodium plus fluorine minus. The same idea works. I take that 1 and put it down there. I take that 1 and put it down there. 1 sodium, 1 fluorine, which means the actual formula is this. Aluminum sulfide, I looked that up on the periodic table. I see aluminum is a +3, so I'll put Al +3. Sulfur is a -2, so I'll put sulfur and a -2. And then let's bring these across. Maybe I'll do it in a different color to make it stand out a little more. So I'll do this to bring the 3 down here. I'll do this to bring the 2 down here. That gives a formula of 2 aluminums and 3 sulfurs. Aluminum sulfide. And this would indeed be a correct answer. The only kind of a hang-up that can potentially come with this, and let me get a fresh piece of paper in order to show this, has to do with what if you have something where the charges are the same. Let me show you what I mean. Well, the charges are the same and not equal to 1. So what I'm thinking is that let's do calcium oxide. So with calcium oxide, we look at calcium. Here it is, a +2. Calcium 2+. Oxygen is a 2-. So that's O2-. So what I'm going to do is bring those charges down. Let's do the crisscross method. I'll bring this 2 down here, and I'll bring this 2 down here. giving a formula of Ca2O2. And if you just wrote that, that would be wrong. This is wrong. What? Why? Because this can be reduced. 2 calciums and 2 oxygens, that's a ratio of 2 to 2, is the same as a 1 to 1 ratio. So I'm going to say reduce the ratio, and we're going to call it calcium oxide. A 2 to 2 ratio is the same as 1 to 1. This would be the correct formula to choose. So you have to be careful with these things, because looking at these, that cannot be reduced. That ratio cannot be reduced. This would be 1 to 1.5. And this one can also not be reduced, 1 to 2. It'd be half to 1 or something like that. No, you wouldn't be able to. So with that being said, this would be pretty much the furthest extent of difficulty you would see on there. So let's do this. How about a couple of practice ones? I'll write some practice ones, and then you, the viewer, can pause to work them out and then see the examples a little further on. So let me see. Let me make some examples up on the spot. We got lithium oxide, calcium phosphide, strontium oxide, aluminum nitride, beryllium fluoride, and one last one, potassium. Let me move that up so you can actually see it. There you go, potassium bromide. Okay, take a moment, work those out, see how you did. I'll start writing these now, so hopefully you've paused and taken a moment to write out what they would be. And now I'll start working them out and explaining why I got what I got. Let's see, lithium's a +1. Oxygen's a -2, so I'll put that 2 there, I'll put the 1 there. Lithium oxide would be this formula. Calcium phosphide, that's calcium is a 2+. Phosphorus is a 3-. Put the 3 there, put the 2 there, and we've got 3 calciums and 2 phosphoruses. Strontium oxide, that's Sr2+ and O2-, again determined by their location on the periodic table. So I'm going to put that 2 down here, put the 2 down there. So Sr2O2 becomes SRO. I reduce because a 2 to 2 ratio is equal to 1 to 1 ratio. Aluminum nitride, that's aluminum 3+, nitrogen 3-. I bring the numbers down, giving me 3 aluminums and 3 nitrogens, which is a 3 to 3 ratio is the same as a 1 to 1, so aluminum nitride. Notice the pattern, by the way. The cation always goes first, the anion always goes second. Cation positive, anion negative. So the positive one's always first, the negative one is always second in the formula. All right, let's see, beryllium fluoride. That's Be2+, F-. 1 beryllium, 2 fluorine, so beryllium fluoride. And potassium bromide. Potassium's a +, bromine's a 1-. Oops, there we go. So 1 of these and 1 of these, so 1 of each, well, that's potassium bromide. Make that R a little clearer. All right, there we have it. And just as a reminder, always make sure to write the negatively charged ion as the second part of the formula, and the first part of the formula should contain the positively charged ion. Okay, there it is.